Good day everyone, welcome to another video tutorial. Today we're going to tackle about the distance between 2 points and how to use the distance formula. In this lesson, we shall use the distance formula to find the distance between 2 points. The diagram shows four line segments, namely AB, CD, EF, and GH. Now let's complete the table and find the lengths of the segment. Let's start with AB. AB, as you can see, if we put it in the Cartesian plane, AB is a vertical line. So all we need to do is to find the vertical distance or how many units or how far A from B. So let's count this 1, 2, 3, 4. So AB has a length of 4 units. CD is an horizontal line. So to find the distance between C and D, we should count how many units C is away from D. So let's have 1, 2, 3, 4, 5, 6. So that is 6 units. Now let's consider the coordinate endpoints of the line EF. E has an endpoints of 8, 2, and F has a coordinate of 8, 8. As you can see, EF has the same abscissa. If the line, if the endpoints of the line have the same abscissa, it says that this line is a vertical line because they lie along the same x coordinate. So to get the distance or the length of this one, we need to calculate the vertical distance. And to calculate the vertical distance, we just need to get the absolute value of the difference of the y coordinate. So in this case, 2 minus negative 8 and get the absolute value of it. So 2 minus negative 8 is the absolute value of 10. So the units or the length of EF is 10 units. Absolute value is the distance of away from zero, so it's always positive. Now let's consider GH. GH, the endpoints of this line is G and H, and it has a coordinates of 9, negative 9, comma 6, and 2, comma negative 6. As you can see, they have the same ordinates. That's why it is a horizontal line. Now let's get the horizontal value or the horizontal length of the line by simply getting the difference or the absolute value of the difference of the abscissa. So that is the absolute value of negative 9 minus 2. Negative 9 minus 2 is equivalent to negative 11. The absolute value of negative 11 is 11. So it will be 11 units. To get the horizontal distance, we just need to get the absolute value of the difference of the abscissa. And to get the vertical distance, we just need to get the absolute value of the difference of the ordinates. Now, what if we are given a line that is neither a horizontal nor a vertical line? So how do we deal with this? Now, let's derive a formula on how to get the distance between these 2 points, point A and point B. The first thing that we're going to do is to the first thing that we're going to do is to assign a variable on each point. Point A will become my point 1 and point B will become my point 2. That's why A is the value of x and y in A is x sub 1 and y sub 1. And on B, x sub 2 or y sub 2. Now let's form a right triangle using these 2 points and create another point. Now let's name these 2 points, then this new point based on the coordinates that we created. As you can see here, the value of x of this one is x sub 2 and the value of y should be y sub 1. So that will be the coordinate of this. Now we created two lines. So that is the vertical line and a horizontal line. Now let's get the distance of this line. Now to get the distance of the new point to point B, We just need, because this is a vertical line, we just need to get the absolute value of the difference of the ordinates. So that is y sub 2 minus y sub 1. On from point A to the new point, to get the distance of this, because this is a horizontal line, we just need to get the absolute value of the difference of the abscissa. So that is x sub 2 minus x sub 1. Now, since this is a right triangle, we can say that the formula for this one is c is equal to square root of a squared plus b squared, because this is the formula for the hypotenuse of the right triangle. Now, let's change this a into this one, and let's change this b to this one, because this is the value of their distance, and will become off of this formula. The distance of AB is equivalent to the square root of the sum of quantity x sub 2 minus x sub 1 squared plus quantity y sub 2 minus y sub 1 squared. So this is now our distance formula. Now let's use the distance formula to answer questions about this. Now without with the Cartesian plane, let's find the distance between points 2, comma negative 3 and 5, comma 1. So first let's write the point and let's assign a variable for them. This will be my point 1 and this will be my point 2. That's why x sub 1, y sub 1. Next, we're going to write down the distance formula and substitute the values that we have. 5 for x sub 2, 2 for x sub 1, and 1 for y sub 2, and negative 3 for y sub 1. Please remember that if you're going to substitute a negative value, just put a close and open parenthesis on it so that you will not be confused of the sign here. Now let's evaluate it further. 5 minus 2 is 3 squared. Then negative 1 minus negative 3 is positive 4 squared. So 3 squared is 9 and 4 squared is 16. So the distance is equal to square root of 25 or 5 units. Remember that the distance is always positive. How far is point 0, comma 3 from 7, comma 2? So let's write the point. And after we write the point, we just assign variables on it. After assigning variable, let's write the distance formula. Substitute all the values that we have. So you can see, let me show you again. X sub 2 is this. X sub 1 is this. Then Y sub 2 is this. I'm sorry, 2. Y sub 1 is 3. So let's simplify it further. 7 minus 0 is 7. And 2 minus negative 3 is negative 1. 7 squared is 49. And negative 1 squared is 1. So 49 plus 1 is the square root of 50. Now let's simplify square root of 50 by factoring it into something that has a perfect square, and that is 25. Now what is the square root of 25 is 5, so that's why we simplify it further. So the distance is 5 square root of 2 units. Which of the points M and N is closer to P? So in this case, we are given 3 points, M and N. We have M and N, and there is a certain point P. So we are asked to find if M is closer to P than N, or N is closer to P than M. So to solve this, we need to calculate the distance between M and P and N and P and compare them to each other. So let's start with the coordinates of M and P. So again, I assign a variables to each point. So in this one, let's start with MP. So let's write the distance formula, substitute all the values that we have, and simplify it further. Now 4 squared is 16 and 10 squared is 100, so that is 116. So that is the distance between M and P. The distance between N and P can be illustrated in this one. So 1 minus 4 squared, because this is 1 minus 4, and 4 minus negative 1. Simplify it further, negative 3 plus 5 squared. So that is 9 plus 25, and that is a square root of 34. Since NP is less than MP, it implies that N compared to M is closer to P. So we have a lesser value than this, meaning this is longer. The distance of this is longer compared to this one. So in that case, N is closer to P. N is closer to P. N compared to M is closer to P. Show that the points A, B, and C are collinear. Now to answer this point, we need to have some illustration. We need to plot this, and if we plot this, we can actually say that it is collinear because they share the same line. But what if we don't have this illustration? What are we going to do? Now let's analyze the problem closer. If if the distance of A and B and the distance of B and C, if we add them together, if that is equal to the distance of A and C, then we can assume that this line is collinear. So what we're going to do is to get the distance of AB, we add this to the distance of BC, and compare it to the distance of A and C. So let's do this. Let's start with A and B. So let's substitute all the values that we have. Again, don't forget to assign values or variables on your given so that you could easily um, substitute it. In this point, I assume that you already know that. So that's why I don't put x sub 1, y sub 1, and x sub 2, y sub 2. And if we simplify it further, we'll get the value of AB as a square root of 13. Now let's get the value of BC. So the distance between B and C is this, is illustrated by this, square root of 13 as well. Now let's get the distance of A and C. Now as you can see, let's equate this. AB plus BC should equal to AC. Now if we substitute the given, we can say that we can factor out square root of 52, and we could bring out 4 because it is a perfect square. So we have 2 square root of 13. Now square root of 13 plus square root of 13 is 2 square root of 13. Since we have shown that AC is equal to AB plus C, it implies that A, B, and C are collinear. Another problem is this. Show that the triangle with vertices 4, comma 4, 1, comma 9, and 9, comma 7 form an isosceles triangle. An isosceles triangle is a triangle that has exactly two equal sides. So we need to find the distance between AB, AC, and BC. Because if we found out that only two sides of these triangles are equal, then it is an isosceles triangle. Again, we need to find all the distance because it might have three similar or three congruent sides, and that would not make this an isosceles triangle. It will make this a equilateral triangle. So let's start. Let's start with AB. So again, let's just substitute the formula to the distance formula and compute it, and we have a square root of 34. AC is a square root of 34 as well. So we have two congruent side by now. Now the next is test the other one, BC, if it is not square root of 34. Okay, since we only have two sides that have the same distance, therefore we can conclude the triangle ABC is an isosceles triangle. Another application of the distance formula is to show that the triangle with vertices P, A, and B with the following coordinates form a right triangle. Now, how can we know if a triangle is a right triangle? So, a right triangle should follow the formula of a squared plus b squared is equal to c squared. Meaning we need to get all the sides of it, and let's choose the longest side as its hypotenuse. And let's assign that other two leg as A and B. And we follow this formula and let's see if it will become equal. And if it is become equal to this formula, then the triangle is right triangle. So again, let's use PA first. PA, and we get the distance of PA. PA is 5. AB, we use the distance formula for AB. So again, if you're having trouble, let's just assume that this is x sub 1, y sub 1, x sub 2, y sub 2. So x sub 1, negative 1 minus 3. That's how it goes. So negative 3 minus 0, that's how it goes. Then we simplify it, negative 4, negative 3, negative 4 squared is 16, negative 3 squared is 9, and we have a square root of 25. In this case, x sub 1, y sub 1, x sub 2, y sub 2. So negative 4 minus negative 1 and negative y1 minus negative 3. Negative 4 minus negative 1 is negative 3 squared. Then negative and 1 plus 1 minus negative 3 is positive 4 squared. So I'm sorry, I forgot to put squared there. So negative 3 squared is 9, negative 4 squared is 16, 9 plus 16 is square root of 25. So that is 5. Now let's get the other side. This one is x sub 1, y sub 1, x sub 2, y sub 2. So negative 4 minus 3, that is negative 7 squared. Then 1 minus 0, that is 1 squared. Negative 7 squared is 49, and 1 squared is 1. So that would become square root of 50. As you can see, let's simplify it further. So 50 is has a factor of 25 times 2. 25 is a perfect square. That's why we have 5 at outside the square root of negative 2. So now let's compare all of this. And this is the longest side. So this will be the value of our C. And this will be our A and our B. And the A squared plus B squared is equal to C squared. So let's substitute it. So if we squared 5 square root of 2, we will get 25 times 2. So 5 squared is 25 and 5 squared is 25. So 25 times 2 is 50 and 25 plus 5 is 50. So this satisfy the Pythagorean formula. So therefore, it is a right triangle. Now another problem is this. If the distance of the point B and point A is 13 units, find the value of x. The coordinate of B has a missing abscissa. So what do we need to do is to write down all the given and let's assign value. So AB is 13. So let's just do this 13. And x sub 2 is x because we don't have value for that. X sub 1 is 2. So x minus 2. Then 7 minus negative 5. 7 minus negative 5 is 12. So we have that. Now, the thing is, we need to find the value of x. To find the value of x, we need to eliminate this radical sign. So we can do that by squaring both sides. 13 squared is like this. So we squared 13, that is like this one. Now let's isolate this one and let's put this on a single side by transferring it on the other side by subtracting 12 squared both sides. Cancel this, so this will become 13 squared minus 12 squared is equal to x minus 2 squared. Let's just assume that we interchange them. Now let's simplify it further. 169 is 13 squared and 144 is 12 squared. So 169 minus 144, we have 25. As you can see, we still have this squared. To eliminate this, let's get the square root of both sides. So we have x minus 2 is equivalent to square root of 25. Now remember this, the square root of 25 has two values, that is positive, negative 5. Now let's subtract 2 on both. Let's add 2 on both sides to eliminate this 2. Cancel this one. So x is equivalent to so this one, let's add 2 here. So 5 plus 2 is 7. So add 2, cancel this one. Negative 5 plus 2 is negative 3. So x is equal to 7 and negative 3. So these are the values of our x. So that's all for the distance formula. I hope that you learned something today. Hope that it would help you into answering your problems involving distance formula. So that's all for today. Goodbye and thank you.